Welcome to Design, Build, and Deliver with Hart Companies, where we dive deep into the world of life science with leaders who decide, design, and deliver the next generation of pharma and biotech facilities. I'm your host, Samir Kondalia. Thanks for joining me as I interview visionary leaders shaping biotech and pharma facilities from C-suite executives to project decision makers. Hear real stories, industry trends, and actionable insights to help you build your facilities and your career smarter, faster, and better. Let's continue with Design, Build, and Deliver with Hart Companies. My guest in this episode is James O'Keefe. James is Vice President at Hart Engineering Corporation, where he oversees complex mechanical construction projects across life sciences, pharmaceutical, and industrial sectors. Since joining Hart in 2008 as a Northeastern University Co-op student, James has advanced through multiple engineering and project management roles, from a co-op to VP, a real-life example if you need one. With nearly 20 years of experience, he has led some of Hart's most demanding installations in New England. He is deeply engaged in advancing life science industry standards through active participation in the New England Mechanical Contractors Association (NEMCA), the International Society for Pharmaceutical Engineers (ISPE), and the UA Local 51 Joint Apprenticeship Training Committee (JATC). Jim holds a degree in mechanical engineering from Northeastern University. In this chat, Jim and I delve into the intricacies of capital projects, the differences between design build and design assist methodologies, the importance of various drawing types in project management, strategies to avoid delays and cost overruns, and the growing trend of local sourcing in the life science construction industry. Additionally, we address a critical shortage of skilled labor, the value of apprenticeship programs, while also touching on personal insights regarding work-life balance and the importance of effective communication in project execution. I found my discussion with Jim very timely and insightful. I hope you do too. Here's James O'Keefe. Good morning, Jim. How are you doing today?
I'm good, Samir. Good morning. How are you?
Excellent. Thank you very much for joining us today. Knowing your expertise, let's start with something very mundane, or at least something we take it to be very mundane, but it's very, very important, which is in capital projects, what's the difference between design build and design assist? And the reason I'm asking is that if somebody is working on capital project once every 5 years or 10 years, the person might know the difference, but we work any day in and day out. And there are certain pros and cons where we would choose design build versus design assist in certain cases. So if you can talk a little bit about it and maybe give us maybe one or two examples.
Sure. Well, thank you again for having me on. I appreciate the opportunity to discuss with you this morning. So design build, design assist, design build, whereas the owner has selected a firm to act as not only the engineer of record, but also the contractor as well. So it's kind of it's an integrated design package that all of that responsibility is falling on a single entity to complete the usually used for.
Just for quick clarification. So when you say project, like a life science company, for example, they have a capital project, they need to design something, build something. And for that project, you're saying what this is
Sure.
how we would approach, right?
Yeah. So we can take any capital project. If there's a utility improvement for a life science company, for example, say you're replacing an air compressor for as part of your process air system, you're going to essentially, the owner would put out a list of requirements that they're looking for their end use, their system requirements, their URS, and then a design build firm such as ours could take that URS and implement that from basis of engineering, basis of design, all the way to ultimate completion, installation, and validation. So in that example, we would be selected to not only specify the air compressor, specify the piping, the sizing, generate all the P&ID layouts, any valving, instrumentation, so forth. We would then go out and purchase all that equipment, perform the installation, do the final testing, qualification, and verification, and turn over that complete package to the owner under one single contract from the owner. The owner is not hiring a separate architect. They're not hiring a separate MEP engineer. They're not hiring a separate process engineer, a GC, and then ultimately a process piping subcontractor. That's all handled directly under an umbrella such as ours. Whereas in a design assist method, the engineering is being handled prior to, where an engineer is on board prior to any contractor involvement. So the owner has gone out, selected a project, generated that URS. They've gone through some at least initial engineering with an engineering firm, any MEP firm, and is then bringing on a contractor early in the design phase to add in that level of detail for the detailed design, look at constructability, look at logistic planning. How are we actually going to get this into the building? What systems or what other personnel might be affected by it? And then using those services during the design assist phase for a more intricate project. That's more so on the intricate design assist projects that we're seeing. Are you have got general P&IDs and initial layouts from an MEP firm, and then the details and the logistics and the exact coordination of how do we actually implement this and make this project work are all done through the design phase in conjunction with the services of the installing contractor. So you're getting a lot of that feedback back to the engineer and back to the owner in that design assist phase. That's really, really useful for intricate, complex projects, new installation in operating facilities or greenfield facilities, and understanding the full impact that is getting into the detail that typical engineers aren't getting into. We're actually going into final component selection, layouts, routing. How are we actually going to build this and implement it? That's what's discussed during the design assist phase, and that input from a contractor is really valuable in that in progressing the project.
Can you give an example of each where it would be beneficial for an owner to do design build versus design assist?
So I would say on some of your smaller projects that can be more readily defined, design build is a perfect option. If it's on a simpler notion that, I've got a Wi-Fi still, or I've got an air compressor, or I've got a train of bioreactors that I need to replace. They're at the end of their useful life, or we're trying to implement new technology. We're trying to revamp the suite. We've got a set parameters. You've got this space. You've got these utilities. Here's your room. Go ahead and do it. All of that can be handled under a single entity in a design build fashion. Whereas if you've gone through your design, you're mapping out your new facility, you've hired on an engineer and they've given you some preliminary P&IDs, some basis of design concepts. At that point, getting the involvement of a contractor early is invaluable. It really is. It's going to dictate the life cycle of your project completely. But the longer that you wait to have that input on from a firm that actually does this and knows how these things need to go in, the sequence that these operations need to go in, what equipment lead times you're going to be looking at, where we can sequence install, what systems we can get ahead on, what we can't. That information throughout the design assist process really is valuable in a successful project.
Yeah, so it seems that if you want to simplify that, if the project is complicated, but you want certain technical expertise, you start with an engineering firm, but build the other guys in to make sure that what you design before you start building is doable, right?
I mean, we see a lot of designs that are complex and, very well thought through, but they can't be built, or they
Right.
can't be built efficiently. And that's really what I think we bring to the table better than most, is at that from an installation perspective on how are we actually going to do this? How are we going to hit your timeline? How is your building going to maintain all of its other current operations without us completely impacting your facility? How can we minimize utility shutdowns? How can we minimize impacts to current personnel operations? Where are our guys coming in and out of? Where are we getting rid of things? Where are we loading things into? Those kind of things that can be handled. They all do get handled down the line in a typical construction project, but looking at that early from the get-go, so there's no surprises for the owner. I mean, the last thing that we want to do as a contractor is surprise the owner with something that we think that they know and they don't. We want to know these things, discuss them up front, overly discuss them at times so that we're all on the same page, that once things start rolling, then we all have a plan and we can get on board with.
Right. No, absolutely. So this brings me to my second topic of this thing. You already sort of answered that before I asked the question, was that when we do a project, there are multiple types of drawings, right? IFCR, IFC, and as built. So issued for construction review, issued for construction, and as built. Now, if you are doing project for the first time, you might think, well, why do I need three different sets of drawings? Why can't you just make one set of drawings and you use them throughout the project cycle? But it doesn't happen. Now, I may sound like an old man, or at least older than I really am, but there used to be just one set of drawings. I mean, we used to spend a lot of time in design. You have one drawings and you could pretty much use, but now you have these different versions. The drawings constantly kept getting, even after the facility is built, right? So why is that? Why do we have drawings that are issued for construction review, then issued for constructions, can you build it, and then as built to go back and change the drawings as you built it? And I think you already partially answered the question.
Yeah, no, I think especially now that with so many segmented teams, so many players that are involved in these large scale projects, that it's really invaluable to give each respective member, each trade, each discipline their due diligence in reviewing. It's a lot cheaper to change things on paper than it is once it's built. I think that's an obvious fact, but it needs to be stated. And let's do what we can for the owner to keep costs down, to keep their investment in line with what their budget was. So, we'll look at drawings from an IFCR standpoint, and 9 times out of 10, IFCR is got general routings. We really haven't coordinated a space that it's those details aren't there. We haven't looked at valve arrays, porting arrangements, so forth. IFC gives us that next level of detail that we can go out and get our ported diaphragm valve assemblies. We can look at additional sloping. You know, IFCR will have a general routing for that, for a Withy loop, a USP loop, purified water, anything like that. IFC, we're getting into that detail of making sure that everything is drainable, going through all of our sanitization processes, making sure that all of that can be done in a streamlined manner, getting into that next level of detail for IFC. And then as built, this is construction. We plan everything as best we can, but changes do happen in the field, and we need to be able to document those back to the owner, and those are ultimately our final as built set. We minimize that. We like to, we certainly take pride in our IFCs match our as builts. We design everything the way that it should go, the way that we planned it, the sequence, the operation, the logistics. We've thought all that through in our upfront engineering design steps. But, some things shift. Some equipment comes in different than you expected. It doesn't match the cut sheets. A vendor drawing didn't match what you ended up. And you're not going to wait another year for a new compressor or a new Wi-Fi tank or anything like that. You're going to, as long as you can make those corrections, and those corrections are approved by the owner and the engineer record, we can still pass all the quality tests that we've set out, and our standards are up to line, then we can shift on the fly. We're good at being flexible in that, to make changes as they're needed to support the continuation of the project.
And how do all this play part in project delays, cost overruns? And if you can reverse engineer, what would we do at the beginning to avoid project delays and cost overruns?
I think, again, it's starting the conversations early. I know, nobody likes more meetings these days, and I'm right there with you. But
Right.
I like meetings that are productive. I like meetings that have the right stakeholders involved from the get-go. I think of so many projects that we can or could have gone better if the right people were in the room on that first handshake. I've met people 6 months into a job that I've said, "Where have you been? Where
Right.
was your input on this? I would have loved it. These are all fantastic ideas. We should have done things this way, but we're here now." And there's a lot of second guessing that can happen with that. But I think that starting those conversations early with the right people, with the right mindset involved, the right requirements, we can do anything as long as we know it up front. When we get handcuffed is when we're surprised at the end. So those things, and they go hand in hand with cost and schedule overruns. If we know what's needed and we know how it's needed, and everyone's rowing in that same direction, then we're pretty much online at every point and can avoid all that.
Yeah, absolutely. And I also love what you just said. It's it's a lot easier to change things on paper than in the facility. You already said it, but I think it's worth coaching that it all comes down to that. Nobody wants more meetings, but it's a lot easier to make changes in an AutoCAD drawing than
Oh
having
yeah,
to
yeah.
tear down the
Couple of
wall.
clicks of a mouse is a lot easier than, 6 new hand welds. So,
Right.
we'll do that every day.
Right. Another thing in last couple of years, and again it goes back to COVID, is that we are in Boston, New England, and a lot more sourcing has companies are choosing to source a lot more things locally, even if it's slightly more expensive, like skid fabrication, or if you need to build something. Now, those kind of things, not only from foreign countries, but other parts of America. People where they can visit and they have control. So can you speak a little bit about that? What have you noticed and why companies are willing to pay more money just so that they can have those things fabricated locally?
Sure. I think exactly like you said, it's, we have an open door policy that any client can come in here and see what's being worked on for them at any point. We have a segregated clean fabrication facility here in conjunction with our main shop out back that we can do pretty much anything in here. And we're doing, large diameter piping to, vessel and skid fabrication and so forth. Uh, like you said, proximity, control over the project. You can talk to me in the morning and come visit me in the afternoon, and we can review an issue that came up, either virtually in a model or another problem that we're seeing or issue that we're seeing, and talk through it face to face. And you're not doing it through, you know, not worried about time zone changes or trying to travel across the country or across the globe to see what you're actually buying. If you want to see what you're buying and see the men and women who are actually building it and putting that quality and that professional and that craftsmanship into what you're getting, the end product, then we're right here and we welcome the visit.
Right. Yeah, and it's cool for everybody. Now, talking about holistically a project, let's say there is a project. Okay, and there's like lots of piping. It's a GMP facility, but obviously big part of that project is going to be non-GMP. Needs lots of piping and tubing and hoses and all that. The lazy thing would be to just get the best pipe or best something and then just build the whole facility. But that's not really cost effective. There are ways where you need clean pipes. There are ways you can have non-clean pipes, and you can choose different types of piping and tubing and Teflon and all that stuff. You can still meet all the codes and compliance, but you can do it a lot more cost effective. And I'm talking about millions of dollars. How would one go about choosing how to choose which pipe while still being GMP compliant?
I think it's again involving the people and the teams with the experience on a multitude of different materials, multitude of different systems into other facilities and use that experience to your advantage. If we see a job that's spec for skid 40 tank stainless steel pipe for a chill water system that's operating at 35 pounds, we'll say that you're going to be fine with SCED 10 here, or we can do this in tubing and do it orbitally, which will actually be more cost effective than doing hand butt weld or stick weld or socket weld or something like that. So we can look at not only the piping, but the joint configurations, the location, the logistics of how it's getting installed. And we can say overall, yes, orbital welding might be, you know, more costly than anything else. But if you look at the actual install of the project and what we're going to do in order to stick or butt weld here, it's going to be more cost effective to go that way. And we can streamline that. We can add in our prefabrication capabilities, get more done in the field and limit that actual field install. So it's looking at it holistically from not only the material, whether it's, you could get away with a carbon steel versus a stainless steel, or you could get away with a 316 stainless versus a Hastelloy or something like that. A lot of times, and understandably, owners and engineers will overspecify for worst case. And let's look at those worst case examples. Are they realistic? Are we really going to be seeing these? Is the potential for that worst case scenario still accurate? Maybe it was accurate in original design of the project 6 months ago, but some other factors have now been engineered out of the project that you no longer need that higher level or that higher grade material because you don't have that risk anymore. So, and a lot of times, pipe specs are the last things that really people look at changing. Once they're issued, and you think the job's good to go. But if you've done other changes, whether it's through your design assist process or any other changes the owner has made to get rid of those risks, but your piping specs or your P&IDs haven't caught up to change those piping specifications, you're now installing great pipe, but you've engineered out the risk for it or the need for it. So, we'll see a lot that we'll still have Hastelloy valves that are on order from because they need to be ordered 26, 30 weeks ago, but now our lines are only stainless. So we could have saved the owner a significant amount of money and changed from Hastelloy to stainless in the valving and the instrumentation now that the piping is only stainless, something like that. So I think it's tough. It goes hand in hand with you need to define your requirements early, but your requirements change as the design and the engineering becomes clearer. So for us, it's that ability to at least provide that input to the owner, provide that input to another general contractor or anything like that we may be working for, whoever we're working for at the time, to use our experience and use that knowledge and our technical expertise on those aspects to say, here's what we can do to save you some money here. Here's what we can do to increase some time, and using that to an owner's advantage. Use the team that you selected to your advantage because they're here for you. You're a partnership in that team, and use them. So that's anything that I would suggest on those aspects.
Yeah, so it's like knowing when to use Lamborghini and when to use Subaru. They both are good cars.
Right. They're both going to get up the hill.
But they both have different purposes and different price points, right? So you get what you need. I want to talk to you about general topic in our industry. On one hand, we see our friends and family members and all these reorganization and what our industry, pharmaceutical industry, life science industry is going through, a lot of layoffs. But on the other hand, there is also a deficit of skilled labor, skilled tradesmen, people who can do things. We are not just looking for a human body. We are looking for somebody who can do consistently quality work up to the base standards. And there is a shortage. It may be difficult to comprehend for people listening to this, but there is a shortage of skilled labor. And you are that obviously is very dear to your heart. You are doing something in the regard. So what are your thoughts and what are the efforts industry-wide, locally and nationally, which are being done to make sure that we have pipeline of skilled labor?
Sure. Yeah, we're a union signatory contractor. I personally am a trustee on the Local 51, which is our local Rhode Island and Southeastern Massachusetts plumbers and pipe fitters local. I serve as a trustee on the Joint Apprenticeship Training Committee. So I've been intimately involved in not only the training programs that we implement for our apprentices and the type of people that we're looking for to enter the workforce. So, we're seeing from early applicants for a long time, just not a lot of interest in the trades. And I think that's starting to shift, which is really nice to see that we're seeing more and more young, fresh out of high school or have done a few years of college or some other trade school and weren't getting it, weren't really having it. And there used to be that stigma of going into the trades and I think a lot of that is shifting, which is nice to see. It's a valuable profession. It's a valuable career.
And it's technology proof. Most of it is technology proof.
Yeah, I mean, AI is not replacing welders. I mean, there's a lot of robotics and there's a lot of new technology that we're using. AI isn't going to come to your house and fix your toilet. I hate to break it to you. It's not. And, the need for quality trained craftsmen in the industry is bulletproof in life in general. So, we've been very fortunate to partner with not only our local associations, but the unions throughout New England that are really instrumental in training the next generation of workers. There's a shortage. Don't get me wrong. There's a severe lack of tradespeople in the country, and New England is no different. But there have been some strides on the national level. We're starting to see more support in really at a young age that the 4-year college education isn't the right path for everyone. And I think rather than driving young students into that path for no benefit, or to not realize the benefit that these kids, some of them just don't want to do that, and they see the value. Why am I coming out of school with hundreds of $1,000s of debt where I can be making hundreds of $1,000s at the same time?
And
The
also,
apprenticeship program.
yeah,
What's
so
that?
just no, no, just to add one more thing, that if a young person doesn't enjoy sitting down in a classroom, listening to a professor and then having to do the assignments, but if you enjoy working with your hands to build things, then there is no point going to college. There are people, there are industries, and we need
Yeah,
people who can do things with hands. Now, if you want to go to college, fine, but don't
right.
feel compelled to go to college if it's
Right.
not.
And don't get me wrong. I mean, the education that is learned, that is gained through an apprenticeship, I would put on par with any, certainly any 4-year degree. You are a lot of these apprenticeships, ours in particular, they're in class for 3 nights a week, 2 or 3 nights a week, 4 hours a time. Some is classroom training that you're learning the basics, you're learning plan drawing, you're learning how to read set of blueprints, go through P&IDs, learning instrumentation, and actually learning the technical written knowledge of these equipment and systems that we're looking at. And then you're doing the hands-on portion. You're learning rigging, you're learning signaling, you're going through your pipe fitting classes, your fit up classes, your welding, all of that's being done. So, there's certainly a valuable education, and all of that is paid for by the contractors, by the member contractors. So these young apprentices are not paying a dime for their education, and coming out and quickly getting into that six-figure earning mark, um, within a relatively short period of time, compared to others that are coming out of the workforce after a 4-year degree. They're saddled with debt, and it's going to take them a while to get to that point.
So, in the in tradesman tribe, there is also a lot of camaraderie and a lot of support system too. Is you're not alone, right? Somebody
Right.
will tell
Right.
you until you are, because it's in everybody's interest that you
Absolutely.
become the best at
Absolutely.
what you do.
Absolutely.
So, Jim, now let's talk a little bit about you personally. If you had to give a TED talk on a topic, what topic would you choose to give a TED?
How to not work yourself into oblivion. No, no,
I think we also use that one.
no, no. I think that, I try and practice what I preach as best I can. I work hard, and I enjoy time away whenever I can. Love being with my family, love spending time with them, vacationing, go to the beach. And I've got 2 young boys, so I've built more trucks and monster trucks and training sets, and I love it. It's the highlight of my life for sure. So looking forward to coaching more, and getting more involved with their sporting programs as they get older. And kind of, I'm very fortunate. I didn't think that I would be in this position at this age, and I'm very glad that I am. So it's been a great career. It's been a great company, and I couldn't imagine my life being anywhere else. That's for sure.
Well, I'll tell you this, everyone else around you knew you'd be in this position at this age. So, for whatever it's worth.
I appreciate that. I appreciate that.
um, what is something that you have started doing or stopped doing lately because of some changes in your life or because of some epiphany or something?
I think I've tried to lately just kind of regroup at home a little bit more, trying to separate the work life balance as best I can. Spending more time just lounging on the couch with my wife is always a nice thing to do. Watching TV and catching up on shows and movies that we haven't watched in years. So I think it's nice to be with a company, with a group of people that support that and understand the importance of that. So I think it's taken me a while, but trying to realize that you can't work 24 hours a day. You gotta stay back sometimes, and cut back a bit. So I'm working on it.
What
Rome's not built in a day.
what TV shows have you caught up on or have you been watching lately?
I think we've got 3 episodes a year left of Yellowstone. That was a nice one that we just finished up. Uh, I think next on deck for us is probably The Sopranos. We're a decade behind, but we'll get there. It's busy when you've got, you're lucky if you get an hour or so a night
Right.
before something else pops up. But yeah, no, it's good to try and catch up on those things. Shut the brain off when you can a little bit.
Well, I think you'll have a lot of time catching up this. They've been making movies and TV shows for 100 plus years.
Yeah, yeah, exactly. Got my work cut out for me. Yeah,
Yeah, plenty to catch up on. Jim, if somebody wants to get in touch with you for an advice or collaboration, or if somebody has a follow-up question, what's the best way to get in touch with you?
sure. I can give you my email. It's JOKEEFE at heartcompanies.com. Um, I'm always open to new opportunities, new people to meet, and projects, and see if we can help. And if we can help, I'd like to at least hear about what you have going on, and I can try and steer you in the direction. I know I look young, but I've been doing this for just shy of 20 years, so I know
Right.
quite a few people, and I've seen a lot. I've seen a lot. I haven't seen everything. I'll never see everything, but I've seen a lot, so I can try and steer anyone in the right direction as best I can.
Absolutely. And I'm sure you'll hear from people. I'll put all of this in the show notes. Jim, this was very, very interesting. I learned a lot. I'm sure our listeners learned from our conversation. So thank you very much for your
I
time.
appreciate it.
And yeah, thank you very much for sharing everything you did. It was great having you on the show.
No, no, this was great. Thank you so much, Samir. I really appreciate it.
You have a great day. Enjoy the rest of your day.
You too. Thank you.
Thanks for joining us on Design, Build, and Deliver with Hart Companies, where we explore the people, projects, and ideas shaping the future of life science facilities. If you enjoyed this conversation, be sure to follow or subscribe so you don't miss upcoming episodes with more leaders from across the biotech and pharma world. To learn more about Hart Companies, our integrated design, engineering, and passivation services, visit hartcompanies.com, that is HART companies.com, or connect with us on LinkedIn. I'm Samir Gondalia. On behalf of everyone at Hart, thanks for listening. Until next time, build with purpose, deliver with pride.